In today's class, we are going to learn about addition reaction of alkane. Alkane is a hydrocarbon. Alkane is a hydrocarbon because it contains hydrogen. It contains hydrogen and also carbon. So if you check here in this organic compound, you will see that this organic compound here contains carbon and hydrogen. Therefore, it is called a hydrocarbon. It has double bond, which makes it unsaturated. So this alkane also has a double bond, and it is this double bond that makes alkane an unsaturated hydrocarbon. Also, the functional group of alkane is the double bond. So this double bond here is the functional group of alkane. It is this double bond in alkane that allows it to undergo addition reaction. It is this double bond that alkane has that allows alkane to undergo addition reaction. Note, this is very important, that addition of atoms, note, addition of atoms of another element to alkanes always removes this unsaturated nature of alkane and produces a saturated organic compound. So whenever you add an atom, look at here, we have hydrogen atom here, we have carbon atom here. So when you add another atom to this unsaturated hydrocarbon, remember that alkane is an unsaturated hydrocarbon. So when you add another atom of another element here to this alkane, it will remove this unsaturated nature of alkane and now turn it to what? To saturated compound. For instance, for instance, we have an atom of an element X, and we also have an atom of another element Y. So when you take these atoms of another elements and add it to this alkane here, it will change the unsaturated nature of this alkane. It will not change it and turn it to saturated compound. Is that understood now? It will not change the unsaturated nature. Here, you can write here, unsaturated nature. It will change. It will change the unsaturated. This is very important. It will change the unsaturated nature of alkanes to saturated compound. I hope that is clear. To saturated compound. Now, let me tell you something that will interest you. When the double bond in alkane opens up, look at this. This is very important. Here, look at this double bond here. Look at this double bond. This double bond in alkane. When this double bond in alkane opens up, one bond will remain as a single bond. One bond here will now remain as a single bond between these two carbon atoms. So look at it here now. One bond is now remaining. One bond is now remaining. Because here, when these two this double bond here between this carbon number 2 and carbon number 3 opens up here. Look at this here. Here, this is carbon number 2 and this is carbon number 3. So when this double bond here between this carbon number 2 and carbon number 3 opens up, when they open up, one bond will remain as a single bond between this carbon number 2 and carbon number 3. So here now, look at here. This is what carbon number 2 and carbon number 3. Have you seen now that here it is now one bond, one single bond that is now remaining here. And it is now this single bond here that will allow each carbon to bond with atom from another element or molecule. Is that understood now? So when the double bond in an alkane opens up, one bond will remain as a single bond between the two carbon atoms. So here, this one single bond will now remain between the two carbon atoms. And it will not allow this carbon to bond with atoms from another element. That is why we call it addition reaction. For instance, here now we have X atom from another element. We have Y atom from another element. So when this double bond here, when it opens up, so one bond will now remain as a single bond, which is this here. Then which will not allow this atom, this carbon atom here, and this carbon atom here to bond atoms from another element. So, and here we have this X and Y as what? Atoms of another element. Of another element. Therefore, this carbon here now, carbon number 2 now, we now bond with what? Atom of another element, X. And this carbon number 3 here, we also bond with atom of another element, Y. So, and this is what we call addition reaction. But what you have to note here, as I keep emphasizing, is when addition of these atoms of another element to alkane will always remove its unsaturated nature and produces a saturated organic compound. So if you look at this now becomes saturated. This becomes what? Saturated what? Compound. Yes, it now becomes what? Saturated what? Compound. Is that understood? Okay, let's go ahead. You will understand it. Now, we are going to look at 3 types of addition reaction of what? Alkane. Please, I'm going to make this class very simple for you to understand. So pay close attention and don't forget to subscribe to this channel and also share this video with your friends. Now, we are looking at 3 types of addition reaction of alkane. The first one is those with hydrogen. The second one is what? Those with water. And the third one is those with halogens. Now, let's take the first one, which is those with hydrogen. Now, we have it here, addition reaction of alkanes with hydrogen. We can also call it hydrogenation of alkane. Now, take a look at this organic compound here. This organic compound here, it has 3 carbon. 1, 2, and 3. Since it has 3 carbon, it is called prop. It is called prop since it has 3 carbon. And since it has a double bond, it belongs to a group of organic compound called alkane. So we take the ENE from alkane and we add it to this prop, it becomes propane. It becomes what? It becomes propane. So we add E-N-E, so it becomes propane. So propane is the name of this organic compound. Now, this organic compound propane, which is an alkane, is now reacting with hydrogen gas. It's reacting with what? With hydrogen gas. So what happens when this is reacting with hydrogen gas? What happens? Now, this is under a condition that the temperature will have to be 150 Celsius, and it has to be a catalyst called nickel. Called what? Nickel catalyst. So when you react this propane with hydrogen under this very condition, what happens is here, this double bond between this carbon number 2 and carbon number 3 is going to split. They are going to break. So when they break, or when they open up, then one single bond is going to remain. Here, look up here. We also have this carbon number 2 and this is carbon number 3. You will see that here single bond will remain, which now makes it what? A saturated what? Compound. So when this single bond remains here, then it will not give room for this carbon number 2 and carbon number 3 to do what? To get themselves attached or to attract or attach with this hydrogen, which is atom from another element. So this hydrogen here now is what? Is another element. Is that understood now? So this carbon here now is not going to accept what? Hydrogen atom. And this carbon number 3 is also going to do what? Accept what? Another hydrogen atom. And when that happens, another compound entirely will not be formed, which becomes what? A saturated what? Compound. Is that understood? So here now, what happens here now is this carbon number 2 here now, it will not do what? We're not going to attach itself to what? To hydrogen. So this hydrogen here will split. This hydrogen here is going to split. This hydrogen will split here itself and get itself attached to this carbon number 2 and also attach itself to what? This carbon number 3. So here we are now going to have what? Hydrogen here. We are also going to have here hydrogen here again. So this compound is now a saturated what? Compound. Is that understood? So this compound is not what? A saturated what? Compound called propane. Called propane. Called propane. Is that understood now? So it is a saturated what? Hydrocarbon. A saturated what? Hydrocarbon. This is now what? Saturated. Saturated what? Hydrocarbon. Saturated hydrocarbon called propane. I hope that is understood. All right, let's go ahead and take another example. Okay. Here now, we are not taking also the addition of alkane with hydrogen also. So here, let's look at this organic compound here. The organic compound here is known as ethane. This is known as ethane. It is known as ethane. Why is it called an ethane? It is called an ethane because it has two carbons. It has two carbons. So it has two carbons, 1 and 2. So 2 carbon is called X. Then because of the double bond here, this double bond belongs to a group called alkane. So which will now take the ENE from the alkane and add to this earth, it becomes ethane. So this organic compound is called what? Ethane. Now, this organic compound is reacting with hydrogen. It's reacting with hydrogen. Then what happened is, here, this double bond between carbon number 1 and carbon number 2 is going to break and split. When they split, or when they break up, one single bond will remain. Look at it here. One single bond will remain. Let's also label this. Carbon number 1, carbon number 2. So one carbon, once this carbon number 1, this carbon number 2, so one single bond will now remain. What happened is, this hydrogen will now do what? Will now split. Is that understood now? This hydrogen will split and bond to this what? Carbon atom here. So this hydrogen will do what? Will split. It's going to split because it's two atoms here of hydrogen going to split. One will bond with this carbon number 1. Another atom of hydrogen is going to bond with this carbon number 2. Is that understood now? So, and this compound formed is what? Saturated. Saturated compound. Now understood. It is now saturated what? Compound. And the name of this saturated compound is called what? It's called ethane. It's called ethane. It's called ethane. Why is it called ethane? It is called ethane because it has two carbon and it has a single bond. So two carbon is called X. Then because of the single bond, it comes from alkane. So we have it as what? Ethane. So this becomes the new product formed. And this reaction happens under this condition, a temperature of 150 Celsius and using nickel as the catalyst. Okay, let's go ahead. You will understand it as we go also. Now, let's look at addition reaction of alkane with water. Addition reaction of what? Alkanes with water. And we call it hydration of alkanes. Hydration of what? Of alkanes. Now, look at what happened here. How many carbons do we have in this compound? We have two carbons, 1 and 2. Therefore, we call it what? We call it X. We call it X. We call it X. Now, let's look at the functional group. We have a functional group here, which is the double bond. This double bond here belongs to a group of organic compound called alkane. Then we take the ENE from alkane and add it to this X. It becomes ethane. You see that it becomes what? Ethane. Now, what happened is, when this ethane is now reacting with water, when it is reacting with what? With water, what will happen is, this double bond here will break apart. When they break apart, a single bond will remain. Here, have you seen it here now? A single bond is now remaining. Let also number this. This is carbon number 1 and this is what? Carbon number 2. So here, this double bond, which is a functional group typical of what? Alkane group, between this first carbon and second carbon, when it splits or when it breaks apart, one single bond will remain. Look at it here. Look at the single bond that will remain. And when it remains, it will now give room for this first carbon and this second carbon to bond with atom of what? Of this water. Is that understood now? It will give room for this first carbon and this second carbon to do what? To bond with atom of what? Of this water. And that's why we call it addition what? Reaction. Now, what will now happen is, this water here now will break. If it breaks, part of it will get bonded to this carbon number 1, and part of it will do what? Will get bonded to this carbon number 2. So you see, so here hydrogen will get bonded to this carbon number 2. And here also, the OH will get bonded to what? To this carbon number 2. Is that understood now? So look at this now. This OH now is a functional group belonging to what? Belonging to alcohol. Is a functional group belonging to what? To alcohol. Now, let us go ahead and name this saturated compound. Remember that this product produced now is what? Saturated compound. Now, let's go ahead and name this saturated what? Compound. Now, because it has 2 carbon, it is called what? Earth. It is called Earth. Now, because it has what? A single bond, it is called ethane. It is called ethane. So here, let's use another color. It is called ethane. Now, look at this functional group. Because of this functional group here belonging to alcohol, so in that alcohol, this functional group here is what? Is alcohol. It's alcohol. So what we do is we are going to take OL from this alcohol and replace this E with OL. So which is called what? Ethanol. So here now becomes what? Ethanol. We are replacing OL. Instead of the what? OL. So we have replaced this E with what? With OL. So it's not going to be what? Ethanol. Is that understood? That becomes what? Ethanol. So this ethanol is saturated what? Compound. It is saturated what? Compound. And remember, this is the process typical of what? To the industries. This is the process that the industry use to produce what? Ethanol. Is that understood now? And this happened under this condition of high temperature of 330 degrees Celsius and a pressure of 60 atm, atmospheric pressure. And the catalyst used in this process, in this reaction, is what? Concentrated phosphoric acid. This has what? Industrial what? Application. And remember also that this ethane here, remember that after the reaction, when this reaction is completed, the reaction chamber used in this reaction is going to hold what? All this content, all the unreacted what? Ethane, water, and what? Ethanol. Now, what happened is that this content are transferred to a condenser to remove the ethane, because the ethane here has a lower boiling point. Ethane here has a lower boiling point of up to negative 103 degrees Celsius. So you see, the boiling point is much lower. Is that understood now? That it will be removed from the condenser. Then the water here, water has a boiling point of 100 degrees Celsius, while the ethanol has a boiling point of 78 degrees Celsius. Then this water and ethanol will now be transferred. Is that understood? Will now be transferred to another chamber, and it will now be separated by what we call fractional distillation. Fractional distillation. So it has industrial application. Okay, let's go ahead. Now, let's look at addition reaction of alkane with halogens. With halogens. We can also call it halogenation of alkanes. Now, let's look at this compound here. This compound here is called, let's look at this compound. This compound here is called ethane. The compound is called ethane. Why is it called ethane? It is called ethane because it has two carbon attached to it, which is X. And because of the double bond, it is what? Ethane. Now, this ethane is reacting with bromine. With bromine. Then what happened is this particular reaction here is under room temperature. Is that understood now? What happened is this double bond here between carbon number 1 and carbon number 2 is going to split. When they break apart, one single bond will remain. Look at it here. One single bond will remain. Let's also number the carbon. Here, carbon number 1 and carbon number 2. So one single bond will remain. Now, one single bond that is remaining will not allow this carbon number 1 here, and this carbon number 2 here to bond with atom of another element, which is this bromine. So this bromine here now will now split apart, and it will be bonded to carbon number 1 and carbon number 2. So we have here bromine atom, and also here bromine atom. We get bonded to carbon number 1 and carbon number 2. And therefore, saturated compound will be formed. Saturated what? Compound will be formed called dibromoethan. Dibromoethan. That is the name of this saturated compound. Dibromoethan. And it is called di because we have two bromine. We have two bromine. One bromine is attached to carbon number 1, and another bromine is attached to carbon number 2. So we call it di because of the two bromine, di. And because we have single bond here, it makes it what? Saturated. So we have it as what? Ethan. So the name of this new product form is now what? Dibromoethan. Hope you understood. So this is the process called addition reaction of what? Of alkane with halogen. Let's also take example of this addition reaction of alkane with halogen. Good. So let's look at this also. This alkane here is also reacting with with chlorine. Chlorine, you know, is also a halogen. So when it reacts, this is just normal shaking. When you shake it, you have mixed the whole mixture. So when it reacts with chlorine, here the double bond between carbon number 1 and carbon number 2 of this ethane is going to break apart. When it breaks apart, a single bond will remain. that single bond that is remaining will now cause this carbon number 1 and carbon number 2 to do what? To get attached, to bond with atom of another element. That atom of another element is what? Is this chlorine. Is that understood now? So here, this chlorine will not split, then, and it will get bonded to carbon number 1, this carbon number 1 and carbon number 2. So here, we now have chlorine will be bonded here, and that chlorine will also be bonded here. So we now have it as dichloroethan. Dichloroethan now becomes the name of this organic compound. And remember that this is what? Saturated compound. Saturated what? Organic compound. Dichloroethane. So this is just a simple process involved in addition reaction of alkane with halogens. Please, if you find this video interesting, don't forget to subscribe and share it with your friends. See you in the next class. Thank you.